Hi everybody, this is Project 4 for the Multi-Sensor Electronic Learning Board. The Kickstarter and the previous project and product videos are all linked below. Today we're going to talk about the PIR attachment, passive infrared sensor. It picks up on the infrared spectrum given off by the human body. It's a motion detector, so we can actually calibrate it relative to sensitivity on its own, and it plugs directly into the board via 3 female-to-female connectors. We're also going to use our variable resistor for a voltage reference, one of our 2 comparators to invert logic, get to that in a second, our LED as an indicator, and our relay module. And in this experiment you're actually going to need another component that doesn't come with the kit. You're going to need a dollar store AC adapter that you're willing to modify. Again, we'll get to that in just a second. So the PIR module has 3 pins. I'm labeling it 1, 2, and 3. Pin 1, and you can actually see this on the bottom of the board, is labeled 5 volts. Pin 2, the middle pin, is called out for output. Pin 3 is GND for ground. So on the main board there is a PIR pin block with 3 pins. You're going to want to connect pin 1 to the 5 volt line on the sensor board. Pin 2 out to the SIG line, signal input line, and 3 GND to GND on the board. Again, those 3 lines are on the PIR pin block. And by doing that, by making those connections, what you're doing is you're powering the board from the 5 volt. You're powering the board, and internally the SIG line is connected to the PIR line, so you can actually use a female-to-female connector to splice from the PIR line to something else. Now, the output of the PIR module is normally low. When it detects a human presence, the output swings high, depending on the sensitivity. So we're going to be using our active low relay board, and what happens is the relay activates when it has a low signal on it. So if we connected our PIR output, which is normally low, directly to the in pin here, what would happen is the relay would be normally on, and it would turn off when the PIR module detected a human presence. And that's a waste of power, because the relay board takes about 70 milliamps. And we don't want to do that. We want to have the relay turn on when the output of the PIR sensor turns on, when it detects a human presence. So how are we going to do that? We're going to use one of our comparators to invert logic. We have a normally low signal here. We want a normally high signal here. So what we're going to do is we're going to connect the VAR pin, a variable resistor. We'll tune it to 2.5 volts, and I'll show you how to do that in a minute. We've done it in previous videos. And we're going to connect that to our C1 plus pin, comparator 1 positive input. And that's on this pin, and the C1 minus pin, comparator 1 negative input. They're on the comparator pin block. And CP1A, the output of the comparator, is on the main pin block. So we've got 2.5 volts always on the positive line. We're going to connect the PIR pin to the negative input. So what happens is we've always got, if we remember comparators, the output is determined by the voltage at the inputs. If there's more voltage on the positive input than there is on the negative input, the output will be 5 volts. If there's more voltage on the negative input than there is on the positive input, the output will be 0 volts. Excuse me. So, by default, we'll have 2.5 volts on this line. So only when the voltage on the negative exceeds 2.5 volts will the output be brought low. So when the PIR sensor detects a human presence, the output will swing high, so there will be 5 volts here, and there will be 2.5 volts here. So the output will swing low because there's more voltage at the negative than there is at the positive. And that's what we want. Now to calibrate this, we're going to, not even calibrate, just to visualize what's going on at the output, we're going to temporarily connect the CP1A output to our LED, just to see as a visual indicator. By default, the LED should be off, and when it detects a human presence, it should turn on. Now I should mention, when you power up the PIR sensor, the output becomes unstable for between 10 and 30 seconds, and you just have to wait for it to settle, and then it becomes properly operational. Once we've calibrated everything, everything's hunky-dory, we'll disconnect the CP1A output from the LED, and we'll connect it to the in pin of the relay board. Now the relay board has 3 pins, 5 volts in and ground. You might find that the ground wire on it, the ground indicator on it looks like this. Possibly, depending on the relay board. So we connect the 5-volt pin to the 5-volt line in the power supply pin block, the GND pin ground to the common ground on the power supply pin block, and of course the in pin will connect to CP1A. Now we've properly powered the relay board and we're properly driving the relay board. Now for those of you who don't know much about relays, this is a single pole double throw switch. It's an electromagnetic switch. What happens is when the action is triggered, this input is brought low. It creates a magnetic field within the relay that pulls the contact from point A to point B. There's a common pin, a normally closed pin, and a normally open pin. So pin 1 is your normally closed pin, normally connected pin. Pin 2 is your common pin, and pin 3 is your normally open pin. When the relay is off, the common pin is connected to the normally closed pin. And when you turn the relay on, the common pin disconnects from the normally closed pin and connects to the normally open pin. So it's just a high-powered toggle switch. If here's my common pin right at the base of my hand, to the left is the default state, connected to the normally closed pin, and when I turn the relay on, it toggles and connects to the normally open pin. So it's a high-powered switch. We can actually control low-power AC devices with it. So what we're going to do with the AC adapter is, if you buy an AC adapter, and I can't stress this enough, if you haven't worked with the high power, make sure somebody's with you, make sure somebody who knows what they're doing is with you, because you can really shock yourself, you can really hurt yourself. Don't be foolish. Let me go on. So if I've got an AC adapter, dollar store AC adapter, it's going to have 2 wires. You can cut right down the middle and separate the 2 insulator wires, obviously not plugged in just yet. And what you're going to want to do is, it won't matter which of those 2 wires you cut, but you're going to want to cut one of them so that you have 2 essentially flying wires. Connect one to the normally open pin and connect the other to the common pin on the output terminal block. Now what that'll do is it will make it so that there's no connection on the AC adapter. So if you plug this side into the wall, 120 volts, excuse me, or 240 volts depending on where you are, and then you're powering, say, a lamp by plugging into this side, because one of the wires is split, there's no power, there's no complete circuit, so your lamp will not turn on. But as soon as you activate the relay, what happens is, internally, it connects those 2 pins. So you've got your cut wire that's been connected internally through the relay, and your circuit is complete. Now, if you wanted to, what you could do is, if you want something to be normally on, normally connected, and to turn off when the PIR sensor detects something, what you can do is connect one wire to the common pin and the other wire to the normally closed pin. So by default, the relay is off, and the connection is actually being made, because by default, normally closed and connected and common are connected internally. So, and then when the relay turns on, when the relay is activated, when the PIR sensor detects motion, what will happen is it will disconnect, and the common pin will connect to the normally open pin. So you can kind of invert logic there. I use logic, maybe perhaps not the right word to use, but again, think about it. It's just a toggle switch. Activated, not activated. Activated, not activated. Common connected to normally closed when not activated. Common connected to normally open when activated. Hopefully that makes sense. We're going to go through all of this right now, and I'm going to show you how to do this project on the board. On the board, the PIR pin block is right here. The right pin, ground, SIG, and 5 volts. The wire is in the way. You probably won't be able to see it on the board, but it's clearly labeled. On the PIR block, as you can see, blue ground, green, sig, yellow, 5 volts. Yeah, I just used 3 random female to female wire connections. So on the PIR module, from this perspective, ground, blue, green, output, and yellow, 5 volts. You've properly connected your PIR module. So now when we power it up, we'll power it up now. We'll take the PIR pin on the main pin block and connect to the LED just to see how the output is working once we've calibrated it. So I'm going to plug it in, and I'm going to rest the PIR sensor facing up over the AC adapter for this. Now watch the LED. The output is not going to be stable for about 30 seconds. I'm going to move away and continue talking, but I'm going to stay out of the way of the sensor. You'll notice that there's 2 variable resistors on the back of the PIR module. You can tune sensitivity with those, tinker around with it. Again, the PIR pin on the main pin block is connected directly to the SIG pin on the PIR pin block. So we're actually looking on directly on the output of the PIR sensor right now. So I'm going to walk over. It picked me up. Very sensitive. I love this thing. Now if you stay very still in front of the PIR sensor, it gets used to you, and it basically detects changes. So as soon as you move, there we go. So it's a neat little thing. I'm going to move closer to it. The LED will probably turn on and off. So we want to have that output normally high and go low when it detects me. So first of all, we're going to disconnect the PIR pin on the main pin block, and we're going to connect it to the C1 minus pin on the comparator pin block. And then we're going to tune our variable resistor. Now, if you remember from previous videos, our VAR variable resistor is right here, labeled VAR on the board. To turn the voltage up at the wiper on the VAR pin on the main pin block, turn the potentiometer head screw clockwise. Turn the voltage down counterclockwise. So to measure voltage on it, we're going to bring in our multimeter, set to voltage. I'm just going to put the black probe on the back of the regulator because that's the ground line. You can also connect to the ground on the power supply pin block right here. And I'm going to touch the positive probe to the VAR pin, which is on the main pin block. Sorry if my hand gets in the way. So we're at about 1.5 volts. I'm going to tune that up a little bit to about 2.5 volts by turning the VAR pin clockwise. Now let's see what's on that pin now. 1.89 volts. I'm not going to tune it to exactly 2.5 volts, but just so you get the picture. 2.344 volts. That's good enough. So now we're going to connect the VAR pin to the C1 plus pin on the comparator pin block. So now the output is normally high, and I'm going to move in front of the sensor, and it picked me up. There we go. Now our relay board will be turning on. I'm going to move again. So relay on, relay off. Now it's just going to keep triggering on me because I'm right in the way of the sensor. So the output is normally high now. That's great. We're going to connect the relay board now. Pardon the relay clicking. The PIR sensor is picking up my body as I'm right in front of it. We'll do a solid test in a minute. So what I've done is I've connected the 5 volt pin from the relay board to the 5 volt line on the power supply pin block, the ground pin from the relay board to the ground pin, or one of the ground pins on the power supply pin block, and I've connected the CP1A output to the in pin of the relay board, which acts to drive it. So what I'm going to do is I'm going to walk away. We're going to let the PIR sensor settle down. Right now the relay is off. And I'm going to walk over. Picks me up. I'll hide again. Move again. So here's something even neater. I can turn off the light. The PIR sensor will need a second to settle. I'm going to stay perfectly still for a second. Now I'm going to move. It picks me up even in the dark. So if I walk away for a while, if I walk away, the sensor is going to settle, and it's going to the relay is going to stay off. And as soon as someone walks in the room, it's going to turn on. So let's hook this up to a lamp. So what I've done is I've taken a dollar store extension cord, cut one of the wires, split it up, placed one in the normally open pin and one in the common pin. So when the relay's on, it reconnects those two wires together. So now I'm going to plug one end into the wall, and I'm going to plug the other end into a lamp. And I'm going to turn the lamp on, so by default, as long as it's receiving power, it will turn on. I've not plugged anything in yet, but here's my PIR module, my relay module, sensor board, and when I plug my lamp in here, the relay will connect power to it. The main extension cord going back into the wall again has not been plugged in yet. I say this again, and I can't say it enough. Be careful if you've never worked with AC before. It's very dangerous. Make sure someone is with you. Always make sure that when you're working on the leads, especially near the relay, that the plug is not connected to the AC outlet. So next, I'm going to plug the board in. I'm going to plug in the lamp here. I'm going to leave the room and come back in, and when it detects me, it's going to turn the lamp on for a short period of time. I'm outside the room, and I'm going to walk in slowly. Or fast, it won't matter. Motion detected. I'm going to move again. I'm going to leave the room. Again, you can tune the sensitivity on the PIR sensor. I'm going to walk in quickly. So there you have it. Now it'll false trigger because I'm standing right in front of it. Don't worry about that. Actually, I will unplug it now, just because that's going to get a little bit irritating. But that's it. That's an entire little system. Now, here's a challenge to you. We've done enough videos with the monostable multivibrator based on the 555 timer. Why not try to set this up with the 555 timer circuit to make it so that when you activate when the PIR sensor detects you, you can make a really, really long pulse width to the relay, so you activate it and then the lamp stays on for 10 seconds. That's a challenge to you. If you don't know how to do that, go to watch the rest of the videos that are linked below, especially the product videos, and it'll tell you how the 555 timer works in monostable mode and how to lengthen pulses. So that's Project 4. Next we're going to talk about the infrared sensor in Project 5. The VAR variable resistor is circled on the left. Above that, the LED pin is circled as well. The PIR module connects to the PIR pin block in the upper right. On the bottom you see the relay module. On the left hand side you have your inputs and your power supply pins. 5 volts connected to the 5 volt line in the power supply pin block. Ground connected to the ground rail on the power supply pin block. The in pin connected to the CP1A comparator output on the main pin block in blue. The C1 minus pin on the comparator pin block connected to the PIR pin in orange, and the C1 plus pin in brown connected to the VAR pin, the variable resistor output, calibrated to roughly 2.5 volts, 2.3 volts in our experiment.